Since this course is about signals and systems, let's begin by defining what a signal is. Now, before I go ahead and formally define what a signal is, I thought it may be interesting to look at how the dictionary defines the word signal. So I pulled up the dictionary definition online, and I have a few different. They have a few different definitions here. The first one says it could be a sign or an indication. The second one says it could be an act, event, or watchword that has been agreed on as the occasion of concerted action. And B, it says it could be something that incites to action. It says it could be something that conveys notice or warning. And the fourth definition says it's an object used to transmit or convey information beyond the range of human voice. I'm not sure why they particularly add the phrase beyond the range of human voice, but nevertheless, that seems like a reasonable definition of a signal. The sound or image conveyed in telegraphy, telephony, radio, radar, or television. And finally, they define the signal as a detectable physical quantity or impulse, such as a voltage, current, or magnetic field strength, by which messages or information can be transmitted. This is pretty much the closest definition here. This is pretty much the definition that is closest to how we would like to think of a signal in this class. You can see this definition is fairly broad, and it could encompass some other definitions that they have given here as well. Okay, so I'm going to go ahead and define a signal formally in just a few minutes, but before that I couldn't help notice some of the examples of signals that they had given on this page, and I sort of wanted to point that to you as well. So one of the examples of a signal they gave here, you can see here, says he likes her, but he is sending the wrong signals with his constant teasing. Well, that's not one of the kinds of signals that we will be encountering in this class. The second one says the teacher gave us the signal to finish what we were working on and hand in our tests. Well, that could be one of the signals in this class. If you're taking longer than the allotted time to finish your tests, I will be giving the signal for you to turn your tests in. But really, that's not going to be the discussion for the most of the class. So let's go on and start to formally define what a signal is. Okay, you can see it's kind of hard to give a precise definition of this, but what we are generally going to think of as a signal in this class is, you can say a signal is a function of an independent variable . Usually this independent variable will be time, that carries some information. Or describes some physical phenomena. Okay. So what does this mean? Mathematically, what we're going to say is this. We have an independent variable. Usually this is going to be time. And we have another variable x which depends on t. So this is going to be a function of t. So this is going to be our signal. Our signal is going to be mathematically represented as a function of time, namely x of t or y of t or z of t. But what it is that it is a function of the independent variable. Since we will largely look only at time as being the independent variable, I think I will say it's a function of time. Okay, so what does it mean for this to be a function of time? What it means is that for every chosen value of t or every given value of t, x of t takes a particular value. Okay, and often these signals can be described either mathematically. So how can we describe these signals? So what you should think about is to see how you can specify this function of time. So in other words, what I mean by specifying a signal is that I should tell you a way for you to compute this x of t for all values of t. If I'm able to do that, then it means that I'm describing a signal to you, or I'm specifying a signal. So one way to do this is to explicitly write a mathematical expression. So for example, I could write an expression like this. X of t is t times cosine t. So what does this mean? If for any value of t you choose, you can compute x of t, right? So if you take the set of values taken by x of t for all values of t, then this is your signal. Okay, now one of the things that was a bit confusing here in this class, unfortunately all the books use this and it seems to be a little bit unavoidable, is that we will use x of t to denote two things. Okay, on the one hand we will use x of t, so x of t will be used to denote both the signal. So what I mean by that is the actual function of time, as well as the value taken by the signal at time t. Okay, so I may say here is a signal x of t is equal to t times cos t. So that means I'm talking about this particular function of time as the signal. That's what I mean by the first statement here. But x of t is also the value taken by this particular function at time t, right? So for example, I may plug in t is equal to pi. If I plug in t is equal to pi, then I get x of pi is equal to pi times cosine pi, which is actually negative pi. So that would be the value of the signal at time t equal to pi. In general, if we wanted, we could talk about the value of the signal at time t. Okay. So let's come back to this definition here. It says it's a function of time. You may be wondering, this is still a little bit abstract. I mean, what do we mean by functions of time, and why do we really care about these functions of time? So what I thought I would do is we'd do a small example here to give you something that you can relate to quite easily. Suppose you have a cell phone. So you call your friend and you want to tell your friend something on the cell phone. So what happens is there is a microphone in your cell phone and you speak into the microphone. So you have a mic here, and when you speak into the microphone, the voltage, the output of the microphone, is going to change as a function of time. Exactly how it changes as a function of time will be a signal for us. You may get some voltage waveform like this. And in fact, I'm going to show this to you right now. What I'm going to do is, so here is a command in MATLAB. If you don't know what MATLAB is, don't worry about it at this point. I'm just going to record my speech for 5 seconds and then plot it and show to you how this looks. Okay. Alright, so I'm going to start. Oops. I'm sorry. I made a small mistake here. The Aggies will be playing in the College World Series baseball in 2011. Okay, so I recorded 5 minutes of my speech, and let me plot. oops, that's okay. Let me just plot x. Okay, so this is how my speech signal looks. So think of the x-axis as time. Okay, right now it's not in seconds. Okay, the y-axis is actually the voltage at the output of the microphone on my computer. You can see it is a particular function of time. So if you tell me what was the value, if you ask me what was the value taken by this at a particular time, I can go to that particular time and tell you what's the value taken here. And that's what I mean by the value of the function taken at that time. But I could refer to this whole signal as such as also as x of t. Okay. So when you speak into your microphone, this is what happens into your cell phone. So you have this voltage waveform, which is really what you want to communicate to your friend or whoever is speaking on the other side. So this is a signal that carries information that needs to be transmitted. Okay. So these are the kinds of signals we are interested in.